Okay, so then from there, they can have a definition of work. If an object undergoes a straight line displacement s, while a constant force is acting on the object, then the work done by the force on the object is F equals F parallel S, where F parallel is the components of vector F in the directions of the displacement, and S is the magnitude of the displacement. Okay, so here they give us some example of this one. Okay, so let's highlight the key word here. It should be a straight line displacement S, and force here should be a constant force. And then we just care about the components of F, the parallel, so it means that in the direction of the displacement. Okay, and then we have S here, just that the magnitude of the displacement. So here we means it's just the distance, okay, if it's a straight line motion. Okay, so let's see those examples. What does it say? Okay, it say, let me write the definition once again here. Work equals to F parallel times with the S magnitude of the displacement. Okay, so in this case we see that an object is moving from this one to this one. This is the initial position, final position. The force make an angle phi. Okay, then okay, see, they just care about the component on this one, and we know that this one can be treated as a right triangle, right? So in order to find the magnitude of the parallel, that should be the hypotenuse. That would be the whole F here is the hypotenuse in that right triangle, and then times with the cosine of this angle. Because cosine will be the adjacent over the hypotenuse, right? Okay. The force has a component in the directions of displacement. This one, oh, the work on the object is positive. Okay, the object speed up. Okay, you know why the work here is positive? Okay, so if you look at this part, you can see that there's a cosine of phi here, and actually we know that cosine of phi can vary from -1 to like +1, right? So it can be negative. In this case, we can see that 5 is less than 90 degrees, and that's why cosine of an angle that less than 90 degrees is less than 1. Actually, it will be in the zone of the positive, in the positive one. If you have learned about the units circle, then you can know this is the cosine, and if the angle belongs to this first section, I could say that is what area, the one, that I could say that to this one, like 1, 2, 3, 4. If it's in this part 1, then the cosine should be positive. Anyway, so the keyword for you about this one is the unit circle, if you want to look more into this one, but maybe I will set it for another video. I just want to show you all the cosine of this angle, which is less than 90, is positive. That's why it makes the work positive, because here F and S is the magnitude which are positive already. Okay, so next B. Interesting. So it's moving this way, but the force tried to put it back this way. So does this work helpful? I don't think it's helpful at all. But they still say that this one still does some work on the object. Okay, it still does some work. It's just that the work has the common opposite to the direction, so it's not helpful for sure. And if they do that, oh, you see the way they identify the angle? Did you see that? It's a very important point here. It go from the S direction, and then it go from that to the force direction. You see that? It go all the way like that. So that's why now you can see that this angle this time is greater than 90, which if you follow the unit circle, it should be in this zone number 2, and then the cosine here, this part should be like negative. So then it makes this one mathematically, this one is negative. Okay, as they mentioned in here, when the angle is greater than 90 and less than 270 degrees. So anyways, it negative. It makes sense. It means that, okay, I'm also doing some work. I'm the force. I'm doing some work, but I'm just against the motion. I'm not helpful at all. So there should be some negative side to show that I'm not helpful. Okay. Last one. The force is perpendicular to the direction of this displacement. Oh, like what we have seen here, that's this component, the perpendicular component, the normal component in the force, this one. Yeah, well, yeah, because if you just apply the equations again, that should be F cosine of 90, and then cosine of 90 is just like 0, right? 0. So then it will make the whole work to be 0. So when it's 0 work, it means that there's no work on the object when the object travel in this way for that displacement. So we say more generally, if the force acting on an object has a component, oh, that's what you say here, perpendicular to the object displacement, that component does no work on the object. Yes, I can see that. It's so neutral. At least it's not like against the motion and do some negative work, but it does not help at all in the movement in this direction. Okay, so that's the 3 examples of the work done by a single constant force acting on an object. And they also mentioned that the unit of the work should be Joule, because it's related to energy. And they note W is a scalar quantity. Oh, scalar means it doesn't have any direction, okay? That can be positive, negative, or 0. Agree? That's the 3 examples we just see. If an object does not move, then work equal to 0. Oh yeah, for sure. If the object does not move, then displacement is 0, then work is just 0. If force is perpendicular to the motion, then work is 0. Yeah, this is the case. If the sign of the work is positive, that is W greater than 0, okay, then energy is added to the system or object by the force. I mean, it makes sense, right? Yeah, because the object is moving toward forward, and thanks to this force, it can move forward. So actually, the work does help. It means that the energy has been added to the system for it to move forward. Okay. If the sign of the work is negative, then the force is removing energy from the system or object. Let's think. Does it make sense to you? It makes sense to me, because if the force does not really help in the motion, actually it tried to pull this one backwards. So it means that the object have to try harder to move forward in order to like balance out the amount that lost due to this force. So I could say yes, it's have make the object have to spend even more energy to cancel out, to balance out for that lost. So it means it's removing energy from the system. Okay, so it makes sense to me. Okay, so anyways, I hope that this review of work is helpful for you in order to identify how to calculate work. And if you want, you can have a look at the work kinetic energy in the previous video. So I guess that for now we're pretty good with the concepts, and then we can move on with the other step to solve specifically for this problem. Thank you. Please let me know if you have any questions in the comments below. See you soon.